So Chandra is a technical fellow and distinguished engineer at BNY Mellon Bank. He's also a Java champion since 2019, also a drug leader of NY Java 6. So as we all know, it's among the largest drugs in the world. And he's also a founding leader of Garden State Drug of New Jersey. He's also a frequent speaker at JUGS and many huge technical conferences, such as Oracle Code One, DevNexus, QCon, DOSCon, GITS India, the list goes on. He's in demand. And he has a bachelor's degree in technology, electrical, and electronics engineering from Sri Venkateswara University. I hope I said it correctly. So welcome, Chandra, and the stage is all yours. Thank you.
Oh, thank you, Mary. Thank you, Chicago Java User Group, for having me here. Appreciate this. And I'm looking forward to an interactive session. The way we are going to proceed is we're going to share some code, and I will frequently ask if there are any questions. What I do request from you, Mary, is that if you could moderate the questions for me and let me know so I can spend more time on my screen, I'd appreciate it. Thank you. And hopefully everybody's ready to get started. I'll share my screen now. Bear with me. Okay, so here's my GitHub profile. My GitHub link is github.com/c-guntur.
This meeting is being recorded.
Mary will be posting the links should anyone require these. But this is my main GitHub homepage. I have some GitHub stats. I don't know if anyone is interested. It has a little bit of a bio about me as well, and handles to both our Garden State Java User Group as well as New York Java SIG. I recommend you follow both of them and also follow Chicago Java User Group. These are great groups to follow. I primarily, as you can see from here, I primarily code in Java. Of course, there's some amount of HTML and JavaScript. Surprise, these are my presentation materials when I use reveal.js, which require both HTML and JavaScript. Most of my code is in Java. I have a section on my current abstracts, where I put in everything that I speak about, all the topics that I can cover. And these are my active repositories. I have a Java Katas repo, which is somewhat famous. It's got about 222 stars. I would like more stars from all of you here. And then there's the Paneer Tikka Masala, which is what we're going to talk about today. Now, very quick introduction and overview of the Java Katas. That's not our topic for today, but anything that we cover today, should it leave any confusion with you, there is a Java Futures code kata that is available, which goes into more details about completable futures. So this is a secondary or a fallback option should you face any confusion with the Paneer Tikka Masala kata. It has some amount of code coverage, and basically there are failing unit tests that the kata taker has to go fix, and that is what the code katas are all about. So please do go ahead and check out the Java katas. If you like it, please do hit the start button. I'd appreciate that. With that, I'm going to stop my spiel about Java katas and come back into what our topic for today is, that is Paneer Tikka Masala. So while I go do this, the first thing I'd like to do is turn off my camera because I'll be very animated as I'm going through the session, and I would much rather have you focus on the content rather than on my face. So I'm going to turn off my video for now as I speak. When questions come up, I'll again turn my video back on. Right, great. So without further ado, this is the Paneer Tikka Masala GitHub repository. You can check out the code. The link is included. And don't worry if you don't get the link. When we get to the IDE, you'll see a QR code showing up on my IDE. So you will have another opportunity to get to the actual content. So what is completable futures? I mean, we've seen completable futures being talked about in the past. We've heard about it. So let's try to understand what a completable future is. It's a versatile utility in Java since Java 8, and it provides a means of task execution. This task execution can be either asynchronous or synchronous, and we'll look at both options. A completable future basically implements what is known as a future API, and it also implements what is known as a completion stage API. And we'll take a look at both as we go along. But we have some additional documentation about these three in this kata. So let's go take a quick look at the future API first. A future was created in Java 5, and it's a placeholder for holding the result of a computation task that has not yet been completed. Once the task completes, the future will hold the result instead. There are a very limited number of operations that are available on a future. These are cancel, basically allowing you to cancel a future completion task there is a get operation. There are two get operations, in fact. There is one that retrieves the result directly and one that retrieves the result with a given timeout parameter. So you'll see two operations, an overload of get and get with a timeout. There is an is cancelled operation, which basically verifies that the cancel succeeded. And there is an is done, which is the opposite, which tells us that the result was successfully created and held by the future. So it's basically got some amount of task activity that can be performed. And once the task is performed, an is done returns true. Should you cancel the task, and is cancelled should return false once the future is cancelled. So that is the future API. It's quite simplistic. And it was introduced in Java 5. It worked great, but it was pretty limited, as you can see by the number of operations that are listed in there. Right? So let's then take a look at what completion stage was. This was a newer API that was introduced in Java 8. And a completion stage is an interface that represents the future held the task, whereas a completion stage represents an asynchronous or synchronous computation task. So it's slightly different. A future holds something, whereas a completion state represents the task itself. Now the task performs an action or computes a value and can call other completion stages. So it allows for pipelining of tasks. You can complete a task, move on to create another task that can be performed. And that is what a completion stage is. And a completion stage is basically something that allows you to stage different tasks within a pipeline. There are some method signatures in completion stage that are quite useful and valuable for us to know. There is an apply, there is an accept, and there is a run. Right? These are different operations that we'll look at, but I just wanted to give you a very quick overview that these exist. We'll go through these later. But first, why are we here? What are we talking about? Let's quickly go through that first. We're here talking about Paneer Tikka Masala. Paneer Tikka Masala, for those of you who are not from aware of the Indian ethnic foods, is one of the delicacies in India. And it basically is, paneer is nothing but cottage cheese. Tikka means grill. So you grill cottage cheese and you put them in a masala, which is like a gravy. So that's what Paneer Tikka Masala is all about. So here is a picture of how it looks like. And then here is a recipe. I mean, this is from a website that I just picked up, which was closest to what I cook. So I just included a link so you're aware of how paneer tikka is made. You'll notice that there is a tikka portion, which is nothing but the grilling, and there is a curry or a masala portion. So there are two different portions of how you make this. And we'll see how we can use Java Completable Futures to get this done. There are a few instructions. First, you get all the ingredients, then you make the tikka, then you make the curry, and then you cook them together. And that's exactly how Paneer Tikka Masala is made. As you can see, there are every single picture out here, which is what we'll represent through our code katas. Right? So there is a marination stage, then there is a grilling or roasting stage, and then you basically go add stir fry other vegetables into it, and then you basically make the masala. And that's where you have all the ingredients done, and then you mix them together and you cook. So that's what we're going to do using a Java code. The same thing that we saw here in pictorial form can be converted into a mind map to make Paneer Tikka Masala. First, you check your ingredients. Then you make the Paneer Tikka, which has its own steps. Then you make the masala puree, which has its own steps, and then you cook them together. Right? And there are some things that are optional. For instance, in this case, we can either use paprika or red chili powder. Right? Great. Sometimes you find paprika, sometimes you find red chili powder, maybe you have both. So there is some amount of exception clauses that you may use one or the other. Now, same thing here. There are some dependencies. So first you have to chop whatever you need to chop, that is the cottage cheese cubes, ginger and garlic. Without chopping, you cannot proceed to, mixing the chopped ingredients. So there is a dependency on 2A1 completing before you can go to 2A2. And likewise with 2A3, depends on 2A1 and 2A2 completion. Similar dependencies exist on other aspects, so we'll go through that in our code base. So I just wanted you to keep a reference to this. And the same picture also exists on GitHub if you want to take a look at it in the Paneer Tikka Masala, where you will find a little recipe. You can click on this, it brings up the same image again. Great. So we saw how the recipe looks like both in terms of pictures, which look yum and which make me drool. And then we looked at it from a more computer program perspective of, hey, let's make a mind map out of it. Let's break it down into individual pieces. So we did that. Now, jumping back into the code itself, we were looking at completion stage and why did we get here? So we were looking at some core methods called apply, accept, and run. An apply method immediately implies that you're looking at a function, therefore some mapping or transformation is happening. And how do I know this? Is because if I were to look at the function API in Java, you will notice that it has exactly one method, and that method is an apply. And that is the method we are looking at whenever we encounter a method signature called apply in the completion stage. Similarly, there is an accept method signature. So if your method name has the word accept in it, that's what I mean by method signature pattern. If your method has the word accept in upper or lowercase, it means there is a consumer involved. The difference between, I guess we'll get to the difference in a little bit, but a consumer basically consumes some content from the computation task. So if you, let us say, have an addition completion task, the sum is what is used further in a consumer. A consumer does not return anything, a consumer simply consumes, whereas a function returns something. A function transforms an object into some other object. So if you were doing adding two integers and you had a function that would convert it into a double, that's a integer to double function being used. Whereas in a consumer, it would consume an integer but not return anything. A consumer returns a void. A run is something completely independent of both, where it does not even care about the output of the completion future, but runs something after the completable future completes. So there are three different types of operations: either accept the result and transform it into something, or accept the result and do something with it, or don't even accept the result, just do something after the completion. Right? So there are three different ways in which your completion stage can be handled. There are different kinds of action methods that we will look at. There's a compose, a combine, there is exceptionally, and we'll take a look at that in a few minutes. I just wanted you to be aware that there are three different ways in which you can handle exceptions in a completable future. There is an exceptionally, there's a when complete, and there is a handle API. Now, I'm talking about completable futures, but we are still in completion stage, and I'm very aware of that. I'm just giving you an example. These are the interface methods, and they are implemented in the completable future API. In terms of synchronicity, we already talked about it. We can either have synchronous, where there is nothing in the method signature that indicates asynchronicity, or if your method signature has the word async in it, that implies that the operation is asynchronous. And we'll take a look at both in our examples. Post-execution, you can perform other activities. So for instance, after the completable future completes, you can then do something else in which you can invoke another stage. And if your method signature has the word both, it implies that there are two completable futures that can be acted upon. And if there is an either in your method signature, that implies there are two completable futures, either of which can succeed, and after which something will perform. So these are, I'm just giving you all this information now because we are going to go through this in code, and you will have this as a back reference. So don't worry too much if you're finding this overwhelming. This is something I'm just preparing you for, so you're aware of what our code would look like later. Great. And the last thing we'll take a look at is Completable Future API. And this API is an amalgamation or a combination of future and completion stage. So completion stage is an interface, future is another interface, and a completable future implements both these interfaces and is a class. It provides some static methods in addition to the implemented methods of future and completion stage. So that's what we'll look at. This is an overwhelmingly large amount of API. So I want you to be aware of this. Now, the patterns you'll find in the method name here will include the word run, which implies that there is a task being performed without any kind of return value using a runnable, because runnable has exactly one method, which is a run method. And then there is a supplier method, basically a supply, which is a supplier method, which allows you to return a value, but it doesn't take in anything. So a consumer consumes, a supplier returns. They don't have the opposite ends. And a run is simply an execution mechanism. So there is a run kind of method and there's a supply kind of method when it comes to operation return types. We've already covered synchronicity. If there is nothing in the method signature that indicates synchronicity, it's a synchronous method. If the method signature includes async, it is an async method. Results-wise, future has a get API and that has been implemented. But in addition, a completable future also has a join method. The difference between a get and a join is that a get throws checked exceptions and a join throws runtime exceptions, therefore doesn't have to be in a try-catch block. They're just different ways of getting the same information. In fact, the underlying code is the same. It is just that the exceptions in the case of a get are checked. So you have to put it in a try-catch block of some sort, whereas a join throws a runtime exception. So you have a choice in choosing both. Both should work. You have to make a call based upon what you're looking for. Some examples of methods that look like then compose. We've already seen the then signatures in the past, and we've seen compose combine in completion stage. We've not gone through it. We will go through it in our code. So we're going to ignore these for now, but there are different kinds of methods we will look at. What I want you to focus more on is how a completable future works. A completable future, when created, can have multiple paths. Let's take the path of a success first. So here is a stage, a completion stage, and when the completion stage succeeds, it results in creating an output O, which is then passed to another stage S, which can again generate another output O, and so on. Now, if a stage were to fail, throw an exception, it goes into an exception path, and this exception path can be handled in certain ways. There are 3 ways to handle exceptions. We'll look at those. And once you handle an exception, it may still throw another exception. You don't know, which may again be handled, which may cause you to come back to a success path, and you will go on to what is known as a success path. Should it fail, you will go on to a failure path. And that's how completable futures chain their completion stages and create a pipeline. And these are 2 possible outcomes of a pipeline. There is a success and there is a failure. So you could go through a path of complete success. You could go through a path of, having handled failure, or you could simply have failed completely. There are different options. So we're going to look at most of these in our code base, but this was a very, very quick overview of the different kinds of methods that exist in a completable future. I don't want to bore you with all these details right now. I think we should jump into code, but I'm going to take 2 seconds to see if anyone has any questions. All right. I assume everybody is unmuted and can ask questions, or if there is anyone writing questions in the chat, if someone could just read them out to me, I'll appreciate that. Awesome. I'm going to assume there are no questions in that case. Okay. Let's jump into what we are looking at. Everything that we talked about is also available in our code. So we are just looking at the same content that we looked at on the browser. This is available in code. Give me a second. Need to get rid of this panel. Okay, great. So we just saw the future API, we saw the completion stage API, and we saw the completable future API. So we already covered all this in our browser, so we can skip these for now. What are we doing? We are creating Paneer Tikka Masala, and these are the steps involved. First, check your ingredients, ensure that all the ingredients that are needed for Paneer Tikka Masala are available. Then we look at how we marinate paneer, which is cottage cheese and vegetables marinated in unsweetened yogurt and spices. Then we'll take a look at how to make tikka masala, which is nothing but the tomato puree based gravy with some spices, onions, garlic, cilantro, etc. Then we'll see how we can cook them together, what is done with the cooking. Now these are all how-tos, and there is one final step to actually get them all to work and cook the product. And that's what we'll look at making for today. So before we do anything else, let's quickly run the actual solution to see how our output looks like, so you know what to expect when you get there. And by the way, you should see the GitHub URL link as a QR code here. Please feel free to check that out in case you were not able to copy the URL. Great. Now, if I were to run this as a solution, the first thing I'd see is it goes through and creates a log of a lot of content. And I took a lot of pain creating all these icons, so please do take a look at them when you get a chance. So what am I doing? Here goes the creation of Paneer Tikka Masala. First, you're checking for ingredients, and you find out that there was no garam masala, which is a very important spice. It's a mix of about 9 different kinds of spices, and it's quite useful in a lot of Indian cooking. So that was something that was missing, and you cannot make the dish without that. So we actually decide to go to the store to get it. We go to the store for about 30 minutes, come back, and while we are gone, we see that the dishwasher is running, getting our utensils ready for whatever. We return from the store. We now have garam masala, and we go on to making paneer tikka. We make the paneer tikka, we chop ingredients, and once we chop the ingredients, we mix everything together and we marinate it. So we start the marination process, and as we start the marination process, we can start making the masala, which is nothing but the puree or the gravy. Once again, we chop some ingredients for that. And once we're done chopping, we heat the butter and oil. We crackle some cumin and cinnamon in there. We add some spices. We add salt, sugar, curry powder. We cook the tomatoes. We do everything, and the masala is done. In the meantime, the marination process also completes. And once we're done making both these ingredients, we cook them. So we basically grill our paneer or roast it. If you don't have a skewer or a grill, you'd prefer roasting it. Once we do that, we chop some more veggies. We include the marinated paneer, and then we pour the pureed masala on top of it. We heat them together. We add some cream, some chopped cilantro leaves, and then we wait for about 3 minutes. And we have a choice on whether or not we want to use lemon juice as a garnish. Once again, this is a completable future option, which will be chosen at runtime for us. It'll either choose a yes lemon juice or no lemon juice. Once we do all this, we notice that the Paneer Tikka Masala is ready in 1 hour, 45 minutes. It's an approximation. Every time we run this, it'll be slightly different, but that's okay. That's exactly how cooking works. You cannot have it down to a T in terms of how much time it takes to produce something. So that's what we're going to look at today on how to make Paneer Tikka Masala using our ingredients. Great. So let's go through this code. Let's go back to the README and see what it says. What are we doing here? First, you run the main class. We just ran the main class with the solutions, and I'll talk about this in a minute. You run the main class. It's going to fail. Nothing is going to work. Everything will be broken. And then you're going to go through the recipe parts, and you'll find that there are broken or empty sections of code that have to-dos and hints listed in them. Your mission, should you choose to accept it, is to go fix these to-dos and hints. You repeat these for all recipe parts until everything gets taken care of, all the to-dos are resolved. And then you check your solutions to make sure that you have an expected or desired output as we had it when we ran the solutions. And then you can rinse and repeat it any number of times. That's what we're going to get at. The order of solving is also listed. First, you do part 1, part 2A, part 2B, part 3, and then the Paneer Tikka Masala. They're also laid out the same way on my IDE. The requirements basically are to have Apache Maven 3.6x. I use 3.6.3. JDK 11 or above. I've tested OpenJDK 15, also 16, but I've not updated it yet. I use IntelliJ. I don't know what you set up, but I'm going to show you why I use IntelliJ. One of the outcomes was when we looked at the run, you saw all this colorful output with the emojis. That's very easy to do in IntelliJ. It doesn't work so well in other IDEs. So that was one of the driving factors. And the second is basically, I'm going to show you in a second, is you have color coding of your to-dos. So notice how my to-dos are set up, my hints are set up. That's because I've color coded them. And how do I do this? I go to my IDE, under preferences, I look at my to-do, and I created these to-dos for myself. So for example, if I were to look at to-do, I notice that its background color is set and its foreground color is set. You can do the same. This gives you a much more meaningful view of what you look at in your code. My hints are set up in a different color, my to-dos are set up in a different color, etc. So it makes it easier for me to read. So that was one of the driving factors for using this. In addition, what I do use and recommend is setting up the to-do panel on your IDE, which gives you a total number of to-dos. We have about 25 to-dos to complete today. And how do we go about with this? You notice that there are recipe parts. Each recipe has some amount of to-dos that need to be completed. And the Paneer Tikka Masala, which is the main driver driving everything, has about 7 items to fix. So that's what we're going to try and attempt to do. I will take shortcuts, and I'm letting you know upfront. I don't want you sitting there wasting your time watching me type. So I have live templates set up, and I'll be using the live templates for the demo. You, on the other hand, can feel free to type those out at your convenience, if not as we are doing this together. And should you have any questions, I can always be reached on my Twitter handle at Guntur, which is also listed on the site. So please feel free to use that. So here we go. The first thing we're looking at is checking our ingredients. We have a few ingredients listed, and we need to go check them. Let's go through this code and see what's going on. First, it asks us to successfully find red chili powder. Apparently, we already have red chili powder, so we have to give out a success message saying, hey, we have red chili powder. How do we do this? Here is our first to do. It says, create a completed future. How do I create a completed future? The hint says, use the static CompletableFuture.completedFuture method. Let's copy this and try it out. So if I were to use this, I'm going to go and type this in, and it says, pass in the message of success. Okay, so let's take the success message and copy that. And lo and behold, we are done. So I've marked this to-do as complete. I've sort of turned off the light. The next one shows us that there is an unsuccessful find paprika powder. So in our case, we have chili. We don't have paprika powder. That's okay. We need only one of those. So it says, the hint says, create a completable future, create a failed future, and use a paprika not found exception with the exception message. Okay, so let's do that. So let's do this manually this time. So I'm going to create a completable future dot failed future. And for my failed future, I have to create a new paprika not found exception, and I'm passing it the exception of the exception message. And this is how I've created a failed future. So what have I done here? In my first case, I created a completable future that is already complete. That is something I'm trying to get you to understand, is that you can create pre-completed completable futures. We did that. You can also fail completable futures ahead of time by calling a failed future. These are very useful in certain scenarios, and these are the ways in which you do it. You can create a completed future, which means that the future is guaranteed to complete, and this is the output. Or you can create a failed future, which is guaranteed to fail, and here is the exception it throws. And we will handle these in the next method. So I wanted you to be aware of that. Okay, so let's go mark this to do as complete. Here is our next method, which says check for paprika and red chili powder. The intent is to find red chili powder, but no paprika powder. So we've already done the completed and the failed future. So here is our completable future check for chili powder. And it calls the method successful find chili powder, which is the one we just implemented. Okay, so what does it want? It says get the completed future and see if it is done. How do I do that? Here is my completable future of spring check for chili powder. And right now the to-do indicates that this particular thing is wrong and I have to change this. How do I change this? So I'm going to go check for chili powder and I'm going to see an is done option. So what this does for me is tells me if my completable future succeeded or not. And in this case, it will succeed because obviously we marked it as a successful completed future. So this would be a finished to do here. Now the next thing we do is if we know that this is complete, we're going to try and get the value of this successful result. If you notice, our value should return red chili powder. So let's go see how we can get that. As we've already talked about, there are two operations that we could use. There's a get and a join. In this case, we have a try-catch block, so we will use a get operation. And in the hint, you notice that it says, hey, use the instance method get on check for chili powder. Quite simple. So let's go change that and instead type in check for chili powder dot get. And this is how we'll get the successful result back. Now get throws exceptions. So let's take a quick look at the API itself, and get throws through two exceptions, interrupted exception and execution exception. And these are checked exceptions, as you can see. And so you have to actually do a try catch on both these interrupted exceptions, whereas an interrupted exception itself is a runtime exception, which you don't have to handle. So an execution exception is something that you don't have to handle. So let's take a quick look. Going back here, what do I need? So I currently have a throwable and I should be able to replace it with the two methods I just checked. Okay, what is going on? WebEx is doing something weird here. Okay, so these are the right exceptions to check, which is an interrupted exception and an execution exception. Catching a throwable is generally a very bad idea. You should avoid doing that anyway. So we are now checking for the exact exceptions that a get can throw, and we are handling both of those, and we're just printing the stack trace out. So we just basically saw how we can find out if a completable future is completed, and if it is completed, how to get the value out of it. So those are the two things we've learned from this particular block of this method. The next block of this method says, hey, also check for paprika powder, which was unsuccessful. So how do you do this? We have a when complete, which returns a new completion stage. So let's first quickly cheat and actually solve this problem using templates. So let's go create a template. And the when complete template that I have is right here. So I want to explain the API more than you focusing on me typing and goofing up. So I already have live templates for this. But what does a when complete do? A when complete looks for a completable future and handles both a success, in this case a message, as well as failure. So it's a handler which can handle either or, success or failure. In our case, we know it is a failure because we threw an exception when we created the unsuccessful find paprika powder. Great. So when complete, in this case, we'll only handle the exception portion. And that is what we're doing by warning, saying, hey, you have an exception.get message. And let's take a look at the exception message that we created was paprika powder not found. And that's what it should print out. So let's go back to our solutions and see what it did for the paprika powder. So if you were to look here, one of the items it found is red chili powder was found and paprika powder was not found. And that is what is being printed out by us doing what we just did. Great. So we completed, and here we noticed how we can get a value from a completable future. We saw how we can check if a completable future is done, and we saw how to handle an exception if the completable future failed and threw an exception. So those are 3 different APIs that we looked at in this method. Now, one of the things we also have is a method that currently does nothing. It says get pots and pans ready. This is the dishwasher running, and we'll see why it exists in a little bit. Let me first mark this as complete so we can avoid getting any kind of flare-ups when we look at the to-dos remaining. We have 2 to-dos remaining in the check ingredients. Great. The next one we see is go to the store and get garam masala. We found that garam masala was not there, so we have to go to the store. This takes about 30 minutes. And during the 30 minutes, we want the dishwasher to be running, which is what our get pots and pans ready is. So what are we showing here is that while your completable future executes, it is possible for you to run other activities. And that's what a completable future can help you do. And that's what we're showing with this example is I have a timer. We'll take a look at the timer in a little bit. And I turn on a timer for garam masala shopping. I have a delay reason of why I have a delay. I'm going to a store for garam masala, and I'm going for 30 minutes. So that's what we need to take a look at. Now let's focus on the timer itself. What is the timer for? The timer API here basically allows me to convert 30 minutes into milliseconds. That's all I'm doing here. So what I'm converting in, each minute is mapped into 100 milliseconds. So what I'm essentially saying is 30 minutes maps into 30 milliseconds. And that's what, 3000 milliseconds or 3 seconds. And that's what we're going to look at. So if we go back to the output, you will notice that my store trip started at about 6:48 and ends at about 9:48, which is 300, right? So that's what we're basically converting 30 minutes into milliseconds. And that's what we did. So essentially, it maps for a, give me a second. I'll just show you what I did. Yeah, so here we are. In my source, you will notice that under main, I have a few utilities that are used, and the utility that I'm using is a timer. So the timer basically tells you how to convert from one instance to another, and here is the duration. And going back to the code, let's take a look at what we did here is I created a timer, I have a delay reason, and I need to go to the store using delay minutes. So we'll first look at the API, and then I'll walk you through how this API looks like and why we use delay minutes. So I'm going to go ingredients, and I'm going to go to the store. So here is my API to get garam masala from the store. I go to completable future, and I call what is known as a run async method. A run method is basically something that executes. It does not actually return anything. It's an execution that happens, and a completable future running async basically performs a task on some other thread. We'll take a look at this thread in the output in 2 seconds, but I just wanted you to first understand a run API is essentially an executor. It calls a runnable method, and it executes this runnable block of code. And in the block of code, I have a thread context. Thread contexts are used for logging. You can ignore this for now, but basically this is what allows me to print out what part of the API I'm currently looking at. And this thread context of recipe part value, in our case, is check ingredients. And you will notice that there is a check ingredients showing up here, and that is the thread context I'm setting. This is a map diagnostic context or similar in the logging API. And I'll show you this more of this when we go through the final portions of the code. For now, know that this has nothing to do with completable futures. It has got only things to do with the logging. So I'm going to ignore that for now. But here is the delay minutes, and that's what I wanted to take a look at as an API. Here is your delay minutes, and what I do is I map 60,000 milliseconds, which is nothing but the number of milliseconds in a minute, to 6,000. And that's how I'm converting minutes into milliseconds for us to save on time. I don't want to waste 1.5 hours cooking this right now as we are talking about it. Hence, I created a delay minutes API, and I provide the delay reason, which is what you will see in the output as where do you have it? The store trip for garam masala. And this is the reason, and it is waiting for 30 minutes. And that's what we have indicated as our delay reason above. Okay, so we created a completable future. what is the main thing takeaway here is you can create a run async operation, which runs on a separate thread and executes a runnable operation. So if you were to replace this code with old-fashioned code, it basically is nothing but new runnable of, and you basically are creating a runnable API here. Instead of that, I used a Lambda, which is why you just see the Lambda with the simple parentheses, which does the runnable block, and this is what is executed. Now, another thing that we talked about earlier is that when you have a runnable, a completable future that is executing a run async, you can run something in parallel on the main thread. And here we want the dishwasher running on the main thread. So one of the to-dos we have is to uncomment the dishwasher running cycle, and that's what we can do. So while the completable future is completing, the dishwasher continues to run. And we end the timer when the completable future ends, and we basically return from the store at that point. And that's what we've done. So while we went out to the store and came back, we were able to go run the dishwasher simultaneously, and we have utensils ready for us now. Okay, great. So I'm going to mark this as complete. So we have our complete check ingredients API now. So what did we do? We basically went ahead and we have a few ingredients that we found, and then we checked for paprika and chili powder. We found that we had no paprika, we had chili powder, and we basically were able to log both those. We found that we did not have garam masala, so we went to the store and got garam masala. And should we fail to get garam masala, it'll just log out an error and it'll actually stop the process down the line, and I'll show you where. So that was part one, check ingredients. I wanted to take a quick break and ask if anyone has any questions about what we talked about so far. Mary, are there any questions?
I don't see any questions right now. Does anybody have questions for Chandra? It's been a quiet crowd.
Hopefully people can hear me.
Yeah, I believe so. Yeah, I haven't seen any, complaint that, problem. But I can hear you very well, Chandra.
All right, great. So I'm going to move to the next part of what we need to do, which is to prepare the paneer tikka itself. Paneer tikka is basically the cubes of paneer that are grilled or roasted. So that's what we will do next. So what are we doing in terms of instructions are, we are chopping paneer into small cubes. Paneer is nothing but tofu or something similar. It's cottage cheese. We add in chopped ginger and garlic. We add in coriander powder, which is a spice. Some people call it cilantro powder. We add garam masala, which is nothing but the combination of 9 spices, which is extremely important for us to cook. Paprika or chili powder and salt. Here we don't have paprika powder, so we're going to ignore that part. We basically mix all these together into yogurt that is unsweetened and basically put this out for marination. We basically have to marinate it for 30 to 40 minutes. In our case, we're only going to do it for 30 minutes. And that's what is the intent for make paneer tikka here. That's what we'll take a look at. In terms of to-dos, we only have 3 to-dos here. So we'll spend a lot more time explaining what we did rather than focus on, IntelliJ's magic of live templates. So what is the first method here? We see the first method is chop paneer, and it looks for some prior status. Interesting. We'll take a look at that later. What does it return? It returns a completable future with supply async. In our last bit of code, we saw run async. Run async basically executes something on a separate thread. A supply async, on the other hand, returns a supplier. Okay, so it's basically returning something that will supply you an output. And the output supplier returns a supplier of type string here. Okay, and this is converted into a completable future of type string. So when this completable future does eventually complete, it will return a string to us. So a run async simply executes, while as a supply async returns you a value of the type that you are trying to return for the completable future. In our case, it is a string. So what are we doing? Once again, we have a thread context, and in the thread context, we put paneer tikka as our recipe part value. So when you look at the output for paneer tikka, you'll notice that it shows paneer tikka. And I'll show you the log messages later on how I created them color-coded. It's not of too much importance right now, but this particular text is coming from us creating the thread context. So I'm going to ignore that going forward. So what do we do first is that we log the prior status, whatever it is. We pass this into the method call. We log that prior status, and then we log that we are chopping paneer for 5 minutes. Right? Let's assume it takes 5 minutes for us to chop paneer. Then we chop ginger for 3 minutes with exactly the same kind of content, so I'm not going to repeat myself. Then we chop garlic for about 3 minutes. The same thing repeats itself. So what we have to do is basically chop these three ingredients. There is a method called chop stuff. We have the methods to chop individual things, and we have to put them together in a completable future. So what's our to-do like? It says, compose all the chopping in a chained sequence and then log success. Either use lambdas or method references, since each method takes a prior status string. That's our to-do. The hint says, chain 3 instances of the then compose method on chopping starter. So we have something called a chopping starter here. Okay, it's a completable future that supplies a string back. So when it completes, it should return this string to me when I do a get or a join on it. Then I'm basically calling a then compose. A then is basically an operation that is performed after one operation completes. A compose is basically an addition. Think of it like adding another layer on top of the completable future. So I'm defining a stage and another stage that wraps over it, right? And it takes the output of the prior stage. So that's what a then compose does. Pass on the previous completable future result. I'm consuming that result. And once all chopping is done, call a then apply. Basically, an apply is something that would take a function and transform a value into some other value. In our case, our function basically transforms a string into another string. Okay, so that is the function we will use. So great, we have return chopping starter, which is of no use to us, and let us replace this code with actual a composition of different completable futures. So I have Paneer Tikka Masala, and I'm going to basically chop everything. Here you notice that I have a chopping starter, which is what we created first, and then I compose chopping paneer, chopping ginger, and chopping garlic, all of which take a prior status. Each prior status is basically the status of the previous call. So chopping starter results in this string, which is then passed to chop paneer, which will log that and then log that it is chopping paneer. And once it has chopped paneer, it will return chop paneer to chop ginger, which will print chopped paneer, and then it will print whatever to chop ginger, etc. So essentially what we're looking at is an output that looks like so. Chopping paneer. First it returns the chopping starter, then it returns chopping paneer, chopping ginger, chopping garlic, and completed chopping. So that's what we're going to do with our code, and that's exactly how we've set it all up to work. Great. So, where am I? Okay, sorry, it scrolled up. So then there is a success status of chopping complete, which is what we see as a final string. So we take the last string and use a function to convert our output into another output. So we're not printing chopped garlic, instead we're just printing chopped everything, right? And that's what we've done in this code. What is there to learn here is that I can have completable futures chained by composing more completable futures after the first one completes. So here chopping starter first completes, and if completed, a then compose will call chop paneer, which is another completable future. Once this completable future completes, its output is then passed to another compose method. So this is how I can chain completable futures. This is one way of chaining completable futures by nesting a completable future on top of another. And that's what we're looking at here. The next thing we look at is a mix stuff. Obviously, there is no content here that we need to change. Let me first go mark this to do as done. There's mix stuff, which basically is mixing all the, I got the chopping status, I got my mixing bowl, I added the paneer cubes, I added everything, coriander or cilantro seed powder, the garam masala, the red chili, etc. I added yogurt, and I basically mix these for 5 minutes. So the delay minutes we've already seen mixes things for 5 minutes. One thing to notice is here I call a join method. The join method is similar to a get, but notice I have no try-catch blocks. This is another way of handling completable future results. A get has to be handled in a try-catch block because it throws checked exceptions. A join does not throw checked, it throws unchecked or runtime exceptions, so it does not need a try-catch block. So if a join fails, the system will error out with a runtime exception. So when you're sure, use a join. Your best bet is to use a get if you are unsure. Great. The next step is basically to prepare the Paneer Tikka Masala. What do we do here? We are making the Paneer Tikka, and in order to make Paneer Tikka, we are basically chopping and mixing everything that we have done so far. All these methods are how-tos. Nothing has been done here so far. All these have to be collated because in the end, this returns a completable future to chop stuff. It has not yet chopped anything. The mix stuff returns a string because it already has a join in it, but we have not yet called the mix stuff. So we have to get there. So how do we do this? Here I have a completable future that is basically combining my chopping and mixing in a completable future together. So let's see the hint on what we need to do. Use an instance method then compose on chop stuff and take the resultable completable future and do a supply async to mix stuff. So a supply async basically takes the value of the chopping and returns it to the mix stuff, which then takes the chopping status from there and logs it out. So when you see this completed chopping message, it is not coming from any other method other than from the mix stuff method. So going back, give me a second. WebEx is, I'm sorry, my game is off because of WebEx. It's kind of bringing pop-ups into where I have to navigate to. So we have a supply async method that needs to be called. So let's take a quick look at how we can change this code to supply an async. I'm going to call a I'm sorry, I got the wrong one. Sorry. Okay, so what did I do here? I first chop my stuff. I call the chop stuff method, which returns a completable future. And when it is complete, I then take the output of that chopping stuff, which is a chopping status, and I then compose a completable future supply async that takes the value of the chopping status and passes it to the mix stuff. The mix stuff method essentially logs this out for me and then mixes all the other ingredients together. So that's what we did here. We basically took the chopping and mixing and joined them together as a single completable future. They are composed together. This is another nesting or pipeline that I created. The difference here is that in the first case, we pipelined them in one single method, whereas here we are taking two different completable futures in that have different execution paths and combining them together. So we did that. So I'm going to mark this to do as complete. The next to do is basically to make sure that all these execute. So I'm actually putting in a halting operation that would stop until this executes. And this is where I'm executing the preparation of Paneer Tikka Masala. So how do I do this? I basically have to go create a join method here. And you notice that the join method is similar to a get. It returns me the result, which means it has to wait for the execution of chop stuff and mix stuff. And that's how I join the method. So here, what I've done so far is basically in all the methods prior, I built up blocks of completable futures. And here is the first place where I'm joining them together. And this is where they will all execute and produce a result. Now, this will not be executed until I call prepare Paneer Tikka Masala, obviously. So that is something that will still have to wait. But I have built out the phases on how to prepare Paneer Tikka until this point. So until this point, all we've done is we've chopped, we've composed, we've mixed, and everything is coming to a culmination with this join when this method is called. So not yet. Okay, so I just wanted you to be aware. And then we basically marinate the tikkas for about 30 minutes. And that's what we do by setting in a delay minutes. There's nothing to do here. It's a supply async, which will return a result saying done marinating when the 30 minutes are up. So we've done this part. So I'm going to quickly take another 2-minute break, 2-second break and ask if there are any questions.
So there's a question from Jigar. So I'll read that to you, Chandra.
Sure.
Jigar is asking, is there a reason why you return future in part 1 powder method and then cast it at later to completable future instead of returning completable
in part
future
1
as we did in part 2A? Yeah, that's right. So he's asking. In part
okay.
1
that's a very good catch. Thank you, Jigar. So I just wanted to show you that a completable future is a future. That's the only reason why this exists. This is basically to show that a completable future implements future, and therefore I could return a future instead of a completable future. So when I actually call them, I cast them into a completable future just to show you that. I could very well replace this with completable future and skip this casting. It's just to indicate that completable future, here, let me just show you what I'm talking about. A completable future implements future. That's it. But that's a great question. I don't know if I answered your question.
It's like it's good. Yeah, he said it's good. So
Awesome. All right, let's move on to making the tikka masala. And in interest of time, I think we're left with about 20 minutes or so. So bear with me. I'm going to try and wrap this all up. So to create a masala, basically what we do is masala is basically gravy. So we're going to do a lot of gravy cooking here. And it's got a lot of aroma to it. There's butter, there's cinnamon, there's cumin, onions, garlic. I don't use garlic, but yeah, there are a lot of people who use garlic in this mix. You add salt, sugar, tomatoes. So it's blended together and pureed. So it's a lot of cooking, a lot of aroma, and the base gravy for a lot of, I guess, dishes in India. So you can use this for other ingredients, other dishes too. Anyways, what are we doing here? First thing you'll notice is here we have an introduction of an executor. So I'm going to take a quick break and go back into the actual log and show you what I'm talking about. Everything we have done so far was done on the main thread. So the main thread was executing everything. Ignore the fact that there is a store trip. Ignore that for now. But everything else, all the check ingredients were being done on the main thread. For Paneer Tikka, you notice that since I use completable futures, it seems to get everything from a common pool worker, not the main thread. So it's running on a separate thread, but this thread is coming out of thin air. We don't know where. So by default, a completable future runs on what is known as a fork join pool, which is the common thread pool made available in Java. So if you don't specify anything, Java picks up the most efficient pooling system for threads known as fork join pool and executes all threads on that. So notice every single chopping is happening on exactly one thread. So common pool worker 19 has been chosen to do everything in Paneer Tikka, except when it comes to the next join method where we combine everything being run on another thread. So all the chopping was being done on one thread because it's one single method being executed. And then the join was another method where I told you that I'm not combining every completable future in one go, but combining two different sets of completable futures as an external join in the mix stuff I guess chop and mix stuff method. Now you notice that completable futures were running on common pool, but now when I make masala, you'll notice that instead of using the common pool, I'm using the recipe part threads. These are names of threads, and this is a very unique thread. This looks like something that is Paneer Tikka Masala specific. And how did I get there? So let's first go through that. I created an executor instance, and the constructor actually receives an executor. And where does it receive the executor from? Obviously from the method that is calling everything, creates an executor. And it creates an executor of 10 threads from what is known as a myThread factory. And myThread factory is something that creates a thread with a name of recipe part and %d, which is replaced with a number 0 to 9. And basically, I'm setting the name using the name format and the count of the thread. So since there are 10 threads, they will be numbered 0 through 9. And that's what we're doing with this particular method. Okay, so what I'm showing you is not only can you use the fork join pool, which is commonly available in Java, you can create your own executor thread. Now, I would personally avoid creating executors, but there are some fringe cases where you need to have an executor, and that's when you should start using the executor functionality. I would much rather rely on the fork join pool than on executors. But should your situation demand, you can use executors on the outside, and we'll take a look at this in a minute. Right? So I created an executor, and instead of executing everything on the thread pool, I will now execute using an executor method. Okay? So a supply async in this case is slightly different from a supply async in the prior case. Let's do a quick comparison. In my supply async for chop paneer, or let's take chop ginger because it's common in both. In my supply async method, I do not pass it an executor, so it runs on the fork join pool. But in case of my masala, I am chopping ginger using an executor. The rest of the code remains the same, except that I now have a supply async that takes a second parameter of an executor. So instead of using the fork join pool, I am directing it to my own executor service, which has a limited number of threads. As I mentioned, I would usually avoid doing this, and the only reason you would do it if you were already forced to use an executor service for thread scheduling. Okay, but both APIs work fine. And how do these both look like is if I were to go to Completable Future, you will notice that there is a supply async method that takes in just a supplier and a supply async method that takes a supplier and an executor. So two different method calls. That is the main difference between the two. That is why I repeated chop ginger on both. Okay. So all these methods run through an executor, and you will notice that they now print using a common non-common thread pool, my thread factory thread. And that is the big difference. Also, in addition, we will notice other things, but first let's see what we're chopping. We're chopping onions. Let's see what we have done. We chopped onions, we chopped ginger, we chopped garlic, we chopped tomatoes. So a lot of chopping going on. And now basically we want to combine all these into one. How can I combine these? So I have a chopping starter again, and I'm supplying async the value of chopping. That means I'm starting the process. And then there's an interim message of empty. And when chopping is complete, I want to print this out. So how do I do this? Here it says chain 3 instance methods using a then combine. In the prior version we used then compose, and I kept mentioning that it was a nesting of completable futures on top of each other. A combine, on the other hand, is like a flat map. It is flattening everything out. So instead of me building on top of one another, they're all being built simultaneously, and they're all flattened out into one single operation at the end, right? And the way it works is, instead of using a single function, I use what is known as a bifunction that takes the output of now, or the current completable future, and the next one, and performs some activity with it. So it's an interesting change of paradigm, and let's take a look. Now, it's a lot of code, so I'm once again going to cheat and use my shortcuts, but you should be able to follow along once I've actually done the IntelliJ magic part of it. So let's take a quick look. Paul. So what am I doing? Overall chopping. I have the chopping starter that I already created, and then combine chop onions to that. So basically a chopping starter, then chop onions. And when I combine these two, I take the outputs of both in a bifunction and I log them, and I return an empty message. I'm going to tell you why I have this empty message in the next call. So basically I have chopping starter and I have chopped onions start at exactly the same time, not one after the other. I am basically running both, expecting the outputs of both and doing something with it. But wait, there's more. I do this, and at the same time, I also combine chopped garlic. And I take the previous status, which is nothing but the interim status message, and the chopped garlic message, and I log that, and I return an interim message, and I keep doing that with everything. So basically, what I've done is I have split out 4 different helpers to come help me chop things together. So it's being done in parallel to one another. Now don't confuse this with parallel threads. I'm just telling you that 4 completable futures are executing together here using a then combine. In case of a then compose, one followed another. In then combine, all of them are started at once. That is the biggest difference. And once I'm done with everything, I'm doing a handle async. So handle is the second way of handling success or failure messages. And if there is a failure, it will be in a throwable. But here we have a success, and we basically execute the success method, which is we mark it as chopped complete. Should there have been a failure, you would have handled the throwable and done something with it. So we saw when complete as one option. Handle is another option. We'll look at the third option in a little bit, but these are different ways in which you can handle success or failures. When complete can handle both success and failure. Handle can handle both success and failure. And I'll show you the difference in a little bit. But these are 2 ways in which we can handle exceptions. The third way will come shortly. Great. So we chopped, then combined. Hopefully all of you understood the difference between a then combine and a then compose. That's what we did here. And we joined the overall chopping. So basically we're expecting all this to complete, and that will be complete when this particular method, chop all, is called. And that's how we'll see the output. So quickly referring back to the output, right? What am I doing here? I started chopping onions, garlic, ginger at exactly the same time, almost the same time. You'll notice that, right? Um, and then they complete at their own pace. And once they're all complete, I'm printing out the output together. Okay, that is the big difference between this, where all start at once on different threads and they all complete, and we know that they're complete. In the prior case, everything followed one after the other. Okay, and that is the big difference between a compose and a combine that you can see in the output. Hopefully the explanation is clear, and if it is not, don't worry, we'll have more time later during the Q&A. Now we have about 10 minutes left, so I want to rush through this portion, and then I'm going to take the Q&As as well. Then what do? We heat butter and oil. No to-dos here, so I'm not worried, but basically what we're doing is we are delaying for 5 minutes to heat butter and oil. Crackle cinnamon and cumin, essentially just, stir frying cumin and cinnamon in there for 2 minutes. We are frying the alia, which is onion, garlic, and ginger. And we basically stir fry the onions to the golden brown, once again waiting for 2 minutes. Then we add tomatoes and we cook them together, not much to do. We cool and puree the mix. And here we prepare the masala. So this is what needs to be executed on the outside. It's a public method that returns a completable future. So far, everything we have written has not been invoked. So nothing has happened yet. Things only start happening when we prepare the masala. So what are we doing here? There's a success message saying basic ingredients are cooked. And in order to cook this, we're going to go through the most complex part of this equation, which is we're going to compose, then apply, then accept, then run as different stages. We're first going to compose chopping. Then we're going to, heat and crackle the cumin and cinnamon. Then we're going to fry the onions, garlic, and ginger using an apply method. It's a function, it will transform. And then we'll accept, which is nothing but a consumer, which will consume or log the output of the above operation. And then we'll run, which runs a simple execution, not caring about the actual output, but just caring about the completion of the prior states. So we'll look at all these methods at one go using this particular block of code. So let's see how it goes. So here is the operation in its entirety. What have we done? We first chop onions and garlic. Then we compose async. That means we're running on an executor thread. Async can be run with or without the executor thread. If you run async without an executor, it will use the fork join pool. If you run it with, it'll basically use the executor service. Now, first we compose, which means we are nesting this on top of chopping onions. With nesting heat butter oil on top of onions. And then we compose async another crackle cumin, so another nesting. So basically all these have to happen one after the other. So after onions are chopped, or everything is chopped, then you heat butter, then you crackle cinnamon. They cannot happen in parallel. However, once done, I am then applying async, which means I am taking the value of whatever crackled cumin is, and I am essentially then adding onions to it. So this is basically a consumer. It is consuming activities. It's not going to return anything back to me. So I'm sorry, it's transforming. Apply is a function, so it'll transform and convert the output into another string for me. Then I accept, which is a consumer, which means this is not going to return anything. I'm just logging the output of whatever all these were using the same executor service. And then I run, which again ignores everything from the output perspective, just ensures that this particular previous step is completed, and I log an output of success. So essentially, I have built out a pipeline of completable futures using nesting, using consumption, using just transformation mechanisms, and then finally just executing something if everything was successful. So these are different possibilities or combinations that you have in completable futures. Then we basically cook tomatoes in the spice base, and when complete, we've already seen this before. In this case, I'm just trying to show you that when there is nothing to return, then your return type is a void. So in this case, a completable future that we did returns a void because the last operation we performed was a run, and a run does not return anything. The completable future you create thus has a type void. How do I use a void is when I cook the base ingredients that I created, and once this is complete, I can either get a void value out or I can get an exception if something failed. Here I'm handling the void value. I just don't use it anywhere. Okay, so I'm just calling a method that would invoke the rest of the operations. And then I basically accept this value, I join, and this is how I'm combining all the completable futures to complete. So once I do the join, it is going to perform all these set activities, then cook tomatoes in the spice base, and that is what would return as done making masala. And that was the outcome of making the masala portion. So very quickly on the cooking part, the cooking should have very few to-dos. These should be faster to complete as well. So I have part 3 cooking. Once again, there's chopping. Oh my goodness, so much chopping. It still uses an executor service. Here I'm chopping cilantro for about 3 minutes. And here is the interesting part. I am roasting or grilling paneer. Now, there are two ways in which you can make tikka, which is nothing but roast or grill. Tikka essentially means charring. Okay, so it's darkening or charring. And you can either roast to darken or char, or you can grill. In our case, since we have a choice, we are looking at, hey, should we grill or roast? We would prefer to actually roast because we're missing a skewer. Okay, so that's our hypothetical example. But before we go there, let's first look at some very interesting APIs that Completable Futures provide. It tells you that you can create what is called a delayed executor. How can I create a delayed executor? I already have an executor which can execute things, but what if I wanted to execute something slower? I can create what is called a delayed executor. So let's go create that. So Completable Futures has a delayed executor method, and in this case, my suggested delay is 20 seconds. Okay, so let's see how this works. So I'm going to put in 20. Great. What does it want further? It'll look for a time unit of seconds. So I'm delaying for 20 seconds. And what is this executor on? It's on the actual executor. So given an executor, I can create a separate one that builds off of my current executor, but delays for a time period. That's what we've done here. So the same executor with a delay will be used on one of these operations, so they'll complete later than the other one. And we'll see why this benefits us in a 2-minute second. Okay, so here we have executor, and we've been asked to, let's complete this as we created a to-do delayed executor. And it says use the delayed executor to ensure that we cannot grill earlier than roast. Okay, so we are still searching for our skewers, so we began roasting. How do we emulate that? As that I can use the delayed executor here. So delayed executor will delay by 20 seconds. So my basic grilling process will be delayed. And while that is delayed, my oven roasting can begin. Therefore, I will give preference to roasting over grilling in this case. It's just a hypothetical example of showing you how I can give preference to one completable future over another. So I did that, and I'm going to mark this as complete. And now I have both, and I want to choose the output of either. I don't care if someone grilled the paneer or roasted the paneer. Give me the tikka paneer after you're done. So how do I do this? I use a method called any-off that can take either completion and work with that. So in my case, any-off is a very useful operation because it will either grill or oven roast, but in the end, I want paneer that is tikka'd, and that's what we're going to do here. How do I do this? It's a very interesting operation and something that you should be heavily invested in because this is quite, I'm sorry. Here is the operation. So I have any-off, which means either grill paneer or oven roast paneer if completed, returns me done roasting or done grilling, and I'm going to use that as my output. And once I get that, I accept and I basically log that out using the same executor. So what did I do? I'm going to print out either done roasting paneer or done grilling paneer. And if you look at our output, you will notice that we have somewhere in our code done roasting paneer. And therefore, we gave preference to roasting over grilling because we used a delayed executor for our grilling process. That's what we did. Okay, great. That is any-off, and it's a very useful API. It's something I want you to remember. The important thing to remember about any-off is that both completable futures should have the same type. Otherwise, it won't work. Any-off requires completable futures of the same type. Okay, and that is important for you to know. Okay, so given a few completable futures that have the same return type, you can do an any-off to give preference to any one of those completable futures that complete. It's not limited to 2. It's a var arg, so you can pass it as many completable futures as you want. When we heat the pureed masala we created in the part 2b, we add cream and cilantro to it, and we will delay for 3 minutes for doing that. We garnish, and one of the questions that we want to ask ourselves is, do we garnish with lemon juice or not? Some people love lemon juice, some people absolutely hate lemon juice. So it depends on who's looking. So let's give that choice to the actual code and see how we can use completable futures for that. Here I have lemon juice as a garnish, question mark, depends on the mood. Positive message is yes, negative message is no. How do I handle this? I create what's called a random Boolean. So I don't even know the value, whether it's a yes or no. It depends on whoever is eating at that point. And I'm going to use this random Boolean completable future based upon the value of the random Boolean. So it can either be true or false. So if random boolean.next boolean is true, then I want to use lemon juice. And if it's false, I don't want to use lemon juice. And how do I do this? So the first thing I can do here is, hey, if the random boolean is true, then my boolean completable future is marked as complete with a true. So here is an example of how I can complete a completable future with passing in a value. The opposite is possible where I don't want it to complete successfully, where I can do boolean completable future dot complete exceptionally. And when I complete exceptionally, I can throw throwable. In our case, we're going to throw a no lemon juice garnish exception. So let's take that and we create a no lemon juice garnish exception, and our negative message is what we pass here. So I created a no lemon juice garlic message, and that's what I'm going to pass back. Great. So I now have either a completed successfully or a completed exceptionally. And this is the third way in which we can handle exceptions in completable futures is I can use what is known as a dot exceptionally clause, which will lead us down the pipeline path that we first saw picture to. Very quickly jumping back, I just wanted to show you the picture I'm talking about. This is the exceptionally part that we're covering, where we can go back into a success path. So let's go back and take a look at that code. How do I do this? I can do complete exceptionally handling, and I can do this using what am I doing here? Boolean completable future, then apply. Okay, sorry. So here I have it. I have a Boolean completable future. I know its outcome is either success or failure. I do a then apply if it is successful, but if it is failed, I can do an exceptionally clause. So here are two output paths, the handle and the when complete handle both together. But in this case, I have separated out the handling of a success and a failure. So then apply will be invoked if it's a successful message. Exceptionally will be invoked if it was a failure message. And this is the third way of handling exceptions in completable futures. You have a when complete, which has both outputs. You have handle, which has both outputs, but does not return anything back. And then you have an exceptionally, which can bring you back and can handle outputs individually. So these are three different ways in which exceptions can be handled in completable futures. Great. And the last part of this code is basically to run all of these together. So roast and grill the paneer, chop the cilantro, heat the pureed masala, then add the cream and cilantro, and then cook and garnish. So what are we doing here? We are using an all-off method, which is slightly different from the any off. All-off is basically ensuring that every single completable future listed completes. And once that is done, I am going to change this into a then run async, which will just execute and print the garnish method output for us. So let's do that real quick. So what did I do? I have an all-off method that roasts and grills, chops. Then once I get both of these completed, I then compose an async to heat the pureed masala, add the cream and cilantro, and then run the garnish method call, which will check if lemon juice should be added or not. The all-off is the most important part here. Let's quickly take a look at the all-off method. An all-off method, once again, returns a void. We don't know the type, and completable futures can have different return types. So the void is a return type that says everything succeeded, and that's what we're looking at in an all-off method. The roast or grilled paneer could return a completable future of, say, string. Chop cilantro could return a completable future of integer. It would still work because all of them have to be executed. And once executed, this returns a result of success with a completable future of type void. So if it completes, there is a void or no return type. It just returns a success, otherwise it throws an exception. So after this is done, I'm nesting back a compose twice, and then I run an execution to run the garnish method on top of it. That in sum basically completes how we create all our recipe. And in the end, I'm just quickly walking through what needs to be done to execute this. So this doesn't need a lot of explanation. It just says uncomment this, comment that to make sure that they all work together. So not too much code here. Basically, what I'm doing is I'm first calling the check ingredients. This will check the ingredients and print them out. Then I'm calling supply async to fix, to create the Paneer Tikka Masala. So let's quickly do that. So I basically make Paneer Tikka Masala, prepare the Paneer Tikka, and then marinate it. So I'm calling the two methods to basically prepare and marinate using an executor. Then basically I have Completable Future to create the masala, prepare masala. I just uncommented that. Then make the recipe parts. This is basically another all-off method where I'm going to call the paneer tikka as well as the masala portions to be completed in an all-off. So very quickly, it's an all-off method, and it's as simple as you creating an all-off paneer tikka and masala and joining. So this is what is executing everything together for you. Um, Remember, I just told you all off returns a void, but you still have to join it in order to execute both these, completable features that are listed in the all off. It says uncomment the three lines because we're going to get the values of paneer tikka, get the values of masala, and join the cooking after both are done. So I'm basically blocking my output until I have paneer tikka ready, until I have the masala ready, and then I can begin the cooking. So once I do that, I don't need these two methods, which are only there to ensure that the code won't break when I send it out to you. Same here, this code is no longer required. I wait for the termination of the executor for a certain period of time. There's a healthy practice if you use executors. Always wait because executors may be running slower than what you expect. And once it's done, I'm just giving you a system exit of 0. So essentially, this is what Paneer Tikka Masala has been doing, is that this particular last class has coordinated invoking all the other recipe parts that we created, and everything gets executed because of this. So if I were to run this code now, hopefully it should print everything the way we expect it to, and I won't be embarrassed. And there you go. That's exactly what we did. It took 1 hour 45 minutes for us to make Paneer Tikka Masala. So with that, I'm done. Should anyone have questions, I'm happy to take those now.
Wow, it's amazing, Chandra. You're making me really hungry now. But it's really creative. I like it. It's a very creative way of describing something that otherwise can be, not very easy. So, yeah. It's
Well,
good.
thank you.
So
Should anyone have questions, I'm happy to take those now.
Any questions for Chandra? It's been a quiet crowd of folks tonight. There are comments from Jigar. Very creative. You really worked hard. Good talk. And Niha, this is a great piece of work. So that's cool. But nobody
Awesome.
has
Thank you. Thank you.
And feel free to unmute yourself and turn on your camera too and ask question. This is meant to be interactive. No one has questions? Please quiet.
I think everyone is hungry now.
I think that's what it, yeah, I believe so, Neha.
Well, in that case, I won't hold you up. Mary, back to you.
Okay, well, thank you. Maybe I just have a more like a bit of a curiosity type of question, Chandra, if you don't mind. So I understand, right? Completable future, we're talking about asynchronous dealing with data, all these things. But how does it work, right? Because I've done a bunch of talks, on reactive, right? So reactive also has kind of like the overlapping thing is with the asynchronous, this concurrency, that theme. So could you have done, if you're doing this recipe, doing like a reactive approach, what do you think? Like with,
so
what are the differences?
Absolutely. A reactive is awesome when you're using a stream of outputs. So a continuous flow in which you are basically picking up from that flow and processing it. In our case, we are just looking at deferring executions. So they have different use cases. Both of them are equally valid. Reactive is a use case where you have, let us say, a pipe, a hose of sorts, if I may, that's continuously pumping you content that you need to process. In our case, it's more of, hey, I need this done at a later time. And once this is done, I need you to perform something else kind of a model. So it's basically a future-based approach or a promise-based approach if JavaScript people are out here. Versus a reactive is more like, let me control the flow of the pipe and process it as things come in. So both have their use cases, both are valid.
Yeah. Oh, sure.
The back pressure element, obviously you want to use reactive, but if you want to defer functioning or handle functioning off to another thread, a completable future makes more sense.
Okay. Gotcha. Yeah, that's very clear. Thank you. Yeah. Cool. So does anyone have questions? Really, you're quiet. Yeah. How come? Well, while I'm here too, I was just kind of looking up to see our list of attendees tonight. I noticed some of you too, a lot of you too are not from actually Chicago, and some of you are actually from Bangalore or India somewhere, and even Malaysia, right? Chandra, are you still there? I look and you're from Malaysia. That's pretty amazing. Yeah, we got folks from all over the world. It's really amazing. So, and a few of in Chicago, but also like I think from New Jersey and Pittsburgh as well. And Neha, hello. So good to see you. So yeah, so that's really nice to be able to have folks from other parts, of the world. So thank you and welcome again. So yeah. Yeah. And there's a question now, if I say your name correctly,
Tirumalesh.
How
Yep.
to test. So
Yep.
maybe.
Yeah, how do you test completable futures? The same way you test everything else. You basically create a computable future JUnit test. And if you really wanted that, let me share my screen and show you. So give me a second. I'm going back to sharing my screen and bear with me. That is a great question, by the way, Tirumalesh. So should you want to do that, I have just the right tool for you. This is my other GitHub repository that I was talking about called Java Katas. So if you go to Java Katas, and please do start it if you like it, one of the katas you have there is Java Futures. And the way the code katas work is you have tests, and these tests fail, and you have to go fix them. So let's take a look at some of the tests we have here. And this is how you test completable futures. I have a completable future. I'm asserting it is not null. I'm asserting it is true. I'm asserting its values. And essentially every single test here builds on the complexity, handling exceptions. How do you handle exceptions in completable futures? Using when complete, using handle, using exceptionally, and you can test all of those. And so on and so forth. I mean, this is probably the most exhaustive examples of how you can test completable futures. So if you have questions, please, there's a run async with fork join pool, there's a run async with executor, you can test those, supply async with fork join pool, supply async with executor, etc. So a lot of code in here, and this is very recent. So please do check out this GitHub repo, and this will tell you everything you need to know about how to test completable futures.
Yeah. Oh.
Does that answer your question?
So, yeah. Tirumalesh said, yeah, looks like he said it's good. It's great. Yeah. Okay. All right. Thank you. So,
Thank you.
And thank you.
Thank you,
everyone.
Mary.
Yeah, thank you everyone for coming and joining us tonight. And like I said, if you want to hang out, feel free. I won't turn off this yet, but if you are hungry, please go ahead and have dinner. But I think
I'm not aware of that.
for you.
But thank you so much, all of you.
Thanks.
You're welcome.
Thanks, Chandra.
Thank you. Thank
I'm
you,
gonna
Chandra.
drop.
You can drop to, and it's late for you, Neha, for in the East Coast. Yeah. So thank
I'll
you
ping
for
you.
staying. Thank you. Thank you.